Hello there. In this video, I want to talk about the slopes of parallel and perpendicular lines. And this video is meant to set up future videos where we will go over equations of parallel lines and equations of perpendicular lines, okay? Now, I'm not going to go over the proofs in these videos. I just want to talk about their relationship and the general idea behind them. So if you would like to see proofs of these, then leave a comment in the comment section and I will definitely get on that. So slopes of parallel lines. Now I've drawn an example here of parallel lines. Now it's not hard to understand. It's the definition of parallel lines. Parallel lines don't intersect. If we're solving a system of equations and we have parallel lines, we will get no solution. Okay? So what does that say about the slope? Well, let's take two forms really quickly. Y equals mx plus b. And then let's say y equals mx plus, I'll say, d. Now, these have the same slopes because they are parallel lines, but they don't have the same y-intercept because if they did, they would be the same line, okay? And if we set these equal to each other, substitution style, I get mx plus b equals mx plus d. And I can start combining like terms, and I get subtract mx, cross those off, and I get b equals d. But remember, b does not equal d. So in a solution set, if b equals d, then they are the same line. They are the same line. Whereas if b does not equal to d, then they are parallel lines. Now, this is built on the assumption that we have parallel lines and demonstrating that they do not have a solution. But for this relationship to occur, we had to give them the same slope, okay? That's built off what the idea was when we talked about no solutions. And in a future video, I'll do an example of that. Now, I don't really consider this to be a proof, even though we got pretty technical in it, because it was built off the assumption that they have the same slope, okay? When reality, a proof would consist of, I have parallel lines, I need to show you they have the same slope. So it's kind of a proof of the converse. But again, if you want to see a video of that, leave a comment in the comment section. Let's go ahead and talk about the slopes of perpendicular lines. So in this diagram, I've got two lines. I tried to draw them or sketch them so that they are perpendicular, and I've marked the right angle. Perpendicular lines intersect to form right angles. Now, what would the relationship of their slopes be? Well, it's not hard to tell from this diagram that if we're not talking about horizontal or vertical, those are kind of trivial examples. We're going to set those aside. A horizontal line and a vertical line would absolutely intersect at a right angle. We're not going to talk about those. We're going to talk about non-horizontal and non-perpendicular lines. It's not hard to see this has a positive slope and this has a negative slope. So right off the bat, we have a slope. We don't really even need to prove that. That's kind of obvious from the picture. Slopes of perpendicular lines will have opposite slopes. Now, the part that's not so easy to tell from the diagram, in fact, it's impossible to tell from a generic diagram, is that the slopes will also be reciprocals. Okay? Again, if you want to see a proof of that, leave it in the comment section down below. But for now, this means that if I have a slope, say a over b, and we'll assume both a and b are positive, so a, b are greater than 0, then the slope of the perpendicular line, would be negative b over a. And I do this just to demonstrate to you an interesting property of these slopes is if I multiply them together times negative b over a, these would cross simplify, these would too, and I'd get 1s all around. and I'd be left with -1. So sometimes I've seen it defined as slopes of perpendicular lines have a product of -1, and sometimes I've seen it described, and this is how I personally like to describe it, they are opposite reciprocals, because that gives us a definitive procedure for which to find the slope of a perpendicular line. If you like this video, go ahead and give it a like and subscribe to the channel. And if you want to see more videos like this or have an idea for a video, leave it in the comment section. I will see you for the next video. Thanks for watching.